A fine morning to one and all. Hope all of you are fine and safe. Now, in today's class, we are going to discuss about the different characteristics of sound wave and the types of audible and inaudible sounds. Let us come to the topic now. Now, let us see what is meant by vibration and what is meant by oscillation. Now, in the diagram here, you can see a thread which is attached to a small ball, and the other end is fixed to a rigid support. This is called as a simple pendulum. This simple pendulum, when you just pull it to one side and leave it, it will start moving to and fro, that is front and back. This movement of to and fro is called as oscillation. The motion of the pendulum from one extreme position to the other extreme position, to and fro, back and forth, is called as an oscillation. So those extreme positions are A to B and back to A. So this completes one oscillation. Then what is meant by vibration? These oscillations, if they are performed in a little faster way, then these are considered to be called as vibration. For example, the vibration of tuning fork, the vibration of a blade when plucked, all these come under vibrations. Oscillation and vibration. We have five different characteristics of sound wave: frequency, amplitude, speed, wavelength, and time period. Let us see one by one. Frequency of sound wave. The number of oscillations per second is called frequency. So, if you take the simple pendulum and pull it to one side, position A, for example, then leave it, it starts oscillating. The oscillations performed in 1 second, that is, the number of oscillations completed in 1 second, is called as the frequency of this simple pendulum. It is represented by the symbol nu, and the unit of frequency is hertz. Hz, Hertz is a spelling. The symbol is Hz. The second characteristic of sound wave is time period. The time taken for one oscillation is called time period. To complete one oscillation, how much time it takes, this is considered to be as the time period of that simple pendulum. It is represented by the letter T, and the SI unit is seconds. Time is measured in seconds. The frequency and time are interrelated, and it is inversely proportional. Time is inversely proportional to frequency, that is T is equal to 1 by nu, or nu is equal to 1 by T. Coming to the third one, amplitude. Amplitude of sound wave. The maximum displacement of an oscillating body from its central position is called its amplitude. The extreme positions of this simple pendulum are A and B. The mean position is O when it is at rest. So, the maximum displacement from O to A and O to B, this is called as the amplitude of this simple pendulum. If you consider a wave, it has ups and downs. Ups are called as crest, and downs, that is the valleys, are called as troughs. Crest and trough. The amplitude of sound wave is the height of the crest or height of the trough. So you can take the height of the up or height of the down, that is the valley or the hill. So the crest and the trough, these two, the heights, if you measure, that is also called as the amplitude of that particular wave. It is represented by the letter A, and its SI unit is amplitude is measured in meters. The fourth and the fifth are not given in your textbook, but let us just discuss the speed of the sound wave. Speed is the distance traveled by the sound wave in 1 second or per unit time. Speed, it's represented with capital V, and its SI unit is meter per second. And the last one is wavelength. Wavelength is the length of the wave. If you take one crest and one trough, that is a wave. That is a complete wave. So the length of that wave is called as the wavelength. Wavelength is measured in meters. The SI unit of wavelength is meters, and wavelength is represented by a symbol called lambda. It is written as inverted Y. These are the five characteristics of sound wave. Coming to the loudness and pitch of the sound. Loudness and pitch of the sound. The loudness of sound depends upon the amplitude of vibration. The amplitude is less, the sound is feeble or weak. If the amplitude is more, the sound is loud. So the amplitude you already we have discussed the height of the wave or the maximum displacement of the simple pendulum. So if the amplitude is very high, then the sound is very loud. If the amplitude is less, then the sound is feeble or weak. So loudness of sound depends upon the amplitude. Similarly, the pitch of the sound depends upon the frequency of vibration. The unit of loudness is decibel. It can also be measured in terms of bells or decibels. The pitch of the sound, it can be shrill or flat. It depends upon the frequency of vibration. If the frequency is less, the sound has low pitch, and if the frequency is more, the sound has a high pitch. For example of low pitch, drum, speaking of an adult, the male person, all these have very low pitch. But coming to the frequency of a whistle and the sound of a baby cry, all these have very high pitched sounds. So this is a major difference between shrillness or flatness of a sound, which depends upon the frequency of the vibration. Coming to audible and inaudible sounds. Audible. Audible sounds are the sounds which we can hear. The frequencies are between 20 Hz to 20,000 Hz. Inaudible sounds are the sound frequencies which are less than 20 Hz and more than 20,000 Hz. In between this 20 Hz and 20,000 Hz, the range is called as the audible range, and below 20 Hz and above 20,000 Hz, it is called as inaudible range. Sound frequencies which are more than 20,000 Hz are called as ultrasonic sounds, and the sound frequencies which are less than 20 Hz are called as infrasonic sounds. Some animals like dogs can hear ultrasounds. Bats can also produce ultrasounds. We'll see the applications later. Coming to the range of hearing. The range of hearing is the sound frequencies between infrasonics and ultrasonics, which a normal human ear can hear. Human beings can hear sound frequencies between 20 Hz and 20,000 Hz. Beyond that and below this, beyond 20,000 Hz and below 20 Hz, human beings cannot hear. Only babies, the newborn infants, can hear few infrasonic sounds. Sound whose frequency is less than 20 Hz is called infrasonic sounds. Few animals like dogs, elephants, rhinoceros, whales, etc. produce and hear infrasonic sounds. Sound frequencies which are more than 20,000 Hz or 20 kilohertz are called ultrasonic sounds. Animals like dolphins, bats, rats, porpoises, that is grey color small fish, etc. produce and hear ultrasonic sounds. Bats use reflection of ultrasonic sound waves to detect an obstacle or its prey. Bats, they do not have proper vision during nighttime, and they communicate with the help of the sounds produced by them, ultrasounds. Even to detect a prey or whether an obstacle is there or not, they produce ultrasonic sounds, and they identify the vibrations reflecting back. According to the reflection of the sound produced by them, they will be identifying whether it is a prey or it is an obstacle. So that is how bats will be using the ultrasounds in their this is one of the application of bats. Thank you.